All right, so we're moving more, towards kind of the application of, what we've been talking about. So I'm going to talk a little bit about integration of surveillance data with resistance breeding, and then Zach is going to follow on with some real examples of how this is being used. So mine will be a bit more generic, and then Zach will follow through with specific things. So we've talked about this already, that really your surveillance data, this is why we want to do it. Yeah, it's really got to inform the resistance breeding. Yeah, otherwise, it's nice to do, but there are other reasons probably for doing it. But this has got to be the key one in terms of why you'd want to really do the surveillance. Talk a bit about pathogen changes. Yeah, and communicating those to breeding programs. Using the most virulent isolates in screening programs. Some examples from Kenya and Ethiopia. Understanding resistance genes, susceptibility, and then also a little bit about information, putting information out. So, let's start off with, within the UG99 race group, we've got two variants that are virulent on this gene SR24. Yeah? So when you see the T at the end, that means they've not only got virulence on 31, but they've also got virulence on 24. Yeah? 24 is quite an important gene. It's been used pretty widely in breeding programs throughout the world. Certainly, I think a lot of North American materials carrying 24. I think in Australia, a lot of the material is carrying 24. So for Robert, it's these variants that would be worst case scenario for Australian growers, not the original UG99. So, important gene. 24 virulence we're picking up quite a lot. So the blue or the green on these pie charts are where that's the frequency in the samples of SR24 virulence. Okay? So you can see here Eritrea, Uganda, Kenya, Tanzania. These are really the common variants of UG99. Ethiopia, we picked up one sample back in 2009, I think, that had SR24 virulence. We've never seen it since. Basically, we can't find SR24 virulence in Ethiopia. But we know from the regional perspective, basically every country around Ethiopia has a lot of SR24 virulence. So that's important information. And this is an example of basically, using that surveillance information, the information coming from, sampling, the understanding which pathotypes we've got, to feed into the breeding systems. So there was a cultivar that was called Millennium. It was released in Ethiopia in 2007. It was resistant to the original UG99, so TTKSK. But we realized that the protection in this variety was only SR24. It gave it protection against the original UG99, but against those variants, it's got no protection. That same year, we saw epidemics caused by SR24 virulence in Kenya. There was a variety called KS Mwamba. It was the most widely grown cultivar in Kenya at that time, and it was solely protected by 24. So when we got the mutation and the virulence for 24 with UG99, that cultivar was, was very badly hit. So using this information from neighbouring countries, this was then fed back into the Ethiopian system. So basically, Millennium, it wasn't withdrawn, but there was no promotion done with Millennium. Because we saw that if we suddenly promoted this variety within a year, maybe 2 years, the pathogen would come and we would have a problem. Yeah? So this is one example of, you know, essentially the surveillance, then informing breeding, or in this case, promotion of varieties in another country. And just a little bit more to highlight this. I mean, these are the predominant races that we now have in Ethiopia. So the original UG99, and then now the Digaloo race, TKTTF, these are the main ones. On the North American differentials, you can see out of those, 24 is basically the only one of those genes that's now effective in Ethiopia. And we've seen this almost complete change in the stem rust population from the UG99 to the non-UG99 TKTTF. But as I've just pointed out, we know 24 virulence is all around Ethiopia. So it's a very high risk strategy if the breeders start suddenly putting out 24 in all the cultivars. It would be good for maybe 1 year, maybe 2 if we were lucky, but almost certainly we would see this virulence come in, and that would be our next problem in Ethiopia. So this is, you know, using sort of the rationale for why we need these, you know, the global monitoring systems, you know, covering wider areas. So knowing what's happening in certain countries is useful information for other countries.